Hi, this is Emily Bender from FuturePlus Systems and welcome back to our lab. Today I will be giving an overview of the DDR4 memory technology. This video will be going over the improvements found in DDR4 as it compares to DDR3, along with overviewing the signal groupings and commands of DDR4. First off, what is DDR4? DDR4 is the newest generation of DRAM with the highest data rate transfer speeds on the market and can be utilized by any laptop, workstation, or server. It compares to the previous generation of DDR3 by having lower power consumption, higher density, faster and greater bandwidths, and is more reliable. DDR4 starts out with initially requiring a lower voltage of 1.2 volts as compared to DDR3's 1.5 volts. Lower voltage variants of 1.05 volts have also started appearing on the market. This gives it a 35 to 40% reduced power consumption, making it quintessential for notebooks. It also has higher module density, projected to be up to 4 times that of DDR3, giving DDR4 DIMMs a whopping 512 gigabytes of capacity. Another important feature is its faster transfer speeds. DDR4 can read or write to memory at much faster rates, starting out with transfer rates at 2100 megatransfers per second, which is on the high end for DDR3. It also has planned speed increases projected at 3200 megatransfers per second or higher. This gives DDR4 up to 50% more performance when compared to DDR3. DDR4 is more reliable because it comes with more error detection capabilities. Its data reliability comes with improved cyclic redundancy checks, or CRC, on-chip parity detection for the integrity of the command and address bus, and enhanced signal integrity. Let's take a look at the actual signals on the DDR4 memory bus. These are the signals that go from the memory controller to the DDR4 DRAM. Depending on the application, the DRAM chips themselves can be found on DIMMs, SODIMMs, or directly on the PCB. This is sometimes referred to as memory down. CKT and CKC are the differential clock inputs, with clock true being the positive and clock complement being the negative. CKE0 and CK1 are the clock enables active high. CS0 and CS1 means chip select active low. Chip select provides for rank selection on systems with multiple ranks. C0, C1, and C2 stands for chip ID, which is only used for 3D stacking or 3DS. 3DS is unique only to DDR4. ODT0 and ODT1 stands for on-die termination, which provides termination voltage at the DRAM for write transactions. ACT is the activation command input. RAS stands for row address strobe, CAS stands for column address strobe, and WE stands for write enable. These define the command during the command portion of the cycle. A stands for address and are address bits A16, A15, and A14 respectively when the command is either a read or a write. DM and DBI stands for data mask and data bus inversion. Data mask is the input mask signal for write data. Data bus inversion identifies whether to store or output the true or inverted data. If data bus inversion is low, the data will be stored or output after inversion inside the DDR4 DRAM and not inverted if this signal is high. BG stands for the bank group input, 2 bits that define the 4 different bank groups. BA encodes the bank address, which are the 2 bits that define one of the 4 banks within each bank group. A0 through A17 are the address inputs, which provide row addresses for activate commands and column addresses for read or write commands to select one location out of the memory array in the respective bank. AP/A10 stands for auto precharge. This signal, when sampled high during a read or write command, determines whether auto precharge should be performed to the accessed bank after read or write operation, and auto precharge closes the bank. BC/A12 stands for burst chop, where A12 is sampled during read or write commands to determine if burst chop will be performed. A12 is not used for a column address, but is used during an activate command as a row address bit. Reset means active low asynchronous reset. DQ is the data input or output. If CRC is enabled, then CRC code is added at the end of the data burst. DQST and DQSC stands for the data strobe, output with read data and input with write data, edge-aligned with read data and centered for write data. PAR means the command address and parity input. DDR4 supports even parity check. Alert has multifunctions. CRC error flag and command address parity flag as an output. During connectivity test mode, this pin works as an input. TEN means Connectivity Test Mode Enable. When high, this pin will enable the connectivity test mode. VDDQ, VSSQ, VDD, VPP, VREFCA, and ZQ are all various supply voltages. VSS is ground. So these were the actual signals and signal groupings that appear on the DDR4 memory bus. These signals are encoded to produce the commands in various modes of operation. Next, I will give an overview of those commands, which include read and write commands, power management commands, and maintenance commands. This table shows all 8 read and write commands available in DDR4. I am going to go over the acronyms used here so that these commands can be better understood. RD and WR are simple enough. These commands show whether a read or write command is being done. BL8 stands for burst length 8, meaning 8 bursts of 64 bits, depending on the system, to the memory. BC4 stands for burst chop 4, which is a chopped burst length 8, so instead it sends 4 bursts of 64 bits. The A simply stands for auto precharge. When displayed in commands, it simply means that the bank closes after it is done with that command. Next are the power management commands. These commands and modes significantly reduce the amount of power consumption by the DRAM. First, we have power down entry, or PDE. Active PDE is a power down entry when a bank is open. Then there is precharge PDE, which is a power down entry when the banks are closed. PDX stands for power down exit, which wakes up the memory after it has entered power down mode. SRE stands for self-refresh entry, which is when the memory controller tells the memory to enter into self-refresh mode. This is when the DRAM is responsible for refreshing itself, as no refresh commands will be issued from the memory controller. SRX means self-refresh exit. This is when the memory controller comes back and takes over the refresh responsibilities. Lastly are the maintenance commands provided in DDR4. Our first command is ACT, or activate, which opens the bank. Then there is PRE, which stands for precharge, which closes the bank. DES stands for deselect. This is an idle command. Anytime there is no chip select and the command address is a don't care. NOP, or no-op, means no operation and is synonymous with an idle command. This is when the chip selects are true. PREA is precharge all, closing all banks in a particular rank. REF stands for refresh. For the memory to hold state, it performs a refresh command. ZQCL stands for ZQ calibration long. This is needed at initialization, since initialization takes a longer time period to calibrate the output drivers and on-die termination. ZQCS stands for ZQ calibration short, which is the same as the previous command, but instead is a shorter time period to calibrate. This can be done at runtime. Calibration is needed to account for voltage and temperature variations. New in DDR4 is multipurpose registers, or MPR, their main function being data bus training. Multipurpose register read, MPR RD, reads the training pattern that the memory drives back, and multipurpose register write, MPR WR, writes the training pattern. These training patterns act as a calibration for the data bits. Mode register set, or MRS, is the next maintenance command. MRS is the command the memory controller uses when it wants to program the 7 mode registers of the DRAM. Well, that's it for my overview on the latest generation of DRAM memory, DDR4. Just to summarize my main points again, DDR4 comes with the highest megatransfers per second on the market, with projected speed increases bringing it to 3,200 megatransfers per second. It utilizes lower power consumption with its improved power-saving features and lower voltages. It has higher module density than DDR3. And lastly, it is significantly more reliable due to new and improved error detection features. If you are involved in a DDR4-based project, check out our DDR Detective website at www.ddrdetective.com or at our main product website, www.futureplus.com, or contact us at protocol.decode@futureplus.com. Thanks again for watching this DDR4 video, and we'll see you next time in the lab.